We're now headed into the heart of Atlantic hurricane season, and on cue, Danielle is churning way out in the ocean far from land. And in fact, tropical cyclones, the generic name for tropical depressions, storms, and hurricanes, spend most of their time far from land where we have very few observations. Hurricane hunters don't go out beyond 55 degrees west longitude, so that begs the question, how do we estimate the intensity of tropical cyclones such as Danielle when they're far out to sea? Back in the early 1970s, a scientist named Dvorak developed a method that uses satellite imagery. It's a pattern recognition scheme that uses cloud features in and around the storm to compute an index called a T number, where T stands for tropical. The T number is linked to intensity and a maximum sustained wind speed. T numbers range from 1.0, not even a tropical depression, to 8.0, a powerful hurricane with 170 knot winds. 1 knot is about 1 mile per hour. The features used to compute the T number are the curvature and distortion of the cloud bands and the temperature of their tops. And if there's an eye, the temperature of the eye and of the clouds in the eye wall. The Dvorak technique has been refined, adapted to different oceans, and automated, and it remains the most widely used tropical cyclone intensity estimation method in the world. How good is it? Well, a study of Atlantic tropical cyclones, for which we also have direct wind measurements from the hurricane hunters, found that half the time the Dvorak technique came within 5 knots of the actual maximum wind, and 20% of the time the air was 6 to 10 knots. The air was 15 knots or more about 13% of the time. These are pretty good results considering the estimates come from satellite images. There's another way to get wind estimates over the ocean from space. Some polar orbiting satellites send microwaves toward the water, and by studying the energy that returns to the satellite, you can estimate wind direction and speed at the surface. To see how these techniques are used in practice, here's the National Hurricane Center's advisory last Saturday explaining why what is now Danielle was first classified as a tropical depression. Satellite images indicate that the area of low pressure has become better organized. A long curved band of convection wraps around the southern and western semicircle. The initial intensity is set at 25 knots, which agrees with a Dvorak classification of T 1.5 and a 25-knot ASCAT pass from this morning. ASCAT is the name of the satellite that provides those surface wind estimates using microwaves. Using those measurements and the Dvorak technique gives tropical meteorologists a lot of confidence. Fred is back with the extended forecast next.